Two insulating plates are both uniformly charged in such a way that the potential difference between them is V2 minus V1, that is 20 volts. So 20 volts potential difference is there, that is plate 2 is at a higher potential. The plates are separated by a distance and can be treated as infinitely large. These plates can be treated as infinitely large. An electron is released from rest on the inner surface of plate 1, right? There is an electron and it is released from here. What is the speed when it hits the plate 2, right? There is a small trick, or you can say a small small thing which you can remember. What is asked in the question? They are asking speed. Whenever speed comes into the picture rather than acceleration, right? Whenever speed comes into the relation, try following using the energy equation if possible. Wherever energy equation is possible, you have to use straight away. Don't think about the force equation, basically, because force gives you what? Acceleration. It never gives you velocity. Only the energy equation gives you velocity because of half mv square, right? So wherever speed is mentioned, just think about energy equation first, right? Then go into any other thing. So here, let us see if the electron is released, what is happening. First of all, plate 2 is at a higher potential. That means electric field will be going in this direction. That means on an electron, force will be acting on this direction, right? So that means electron will be moving towards 2 automatically, right? Now what is happening? While moving, it is going from lower potential to a higher potential, right? And since it's an electron, that means it is losing its potential energy. Delta U will be equal to what? Q into delta V. Delta V is 20 volts, but Q is negative. That means minus 1.6 into 10 raised to the power of minus 19. This is the charge on electron, and delta V is 20. Is that right? So this will be what? Minus 32 into 10 raised to the power of minus 19. That means delta U is negative. That means it is losing potential energy. Now since it is losing potential energy, that means this loss, yani 32 into 10 raised to the power minus 19, will be equal to the gain in kinetic energy. And since initially it was at rest, right, because it is given, it is released from rest, and we have to calculate the velocity over here. So the change in kinetic energy will be what? Half mv square, right? And m is given in the question. So that means it implies that v will be equal to under root of 2 into 32 into 10 raised to the power of minus 19 divided by of 9.1 into 10 raised to the power of minus 31, right? So here you can calculate the velocity. So if you see the answer, if you calculate, when you calculate, you'll get the answer as 2.6 into 10 raised to the power 6. So it will be nearly equal to A, right? So this will be the correct answer.